Okay. So till now, whatever the protocols we have seen, those were about switching. Okay. So almost we completed the switching. And today we're gonna start with routing. Okay. So Pratik, what is route? Routing, router.
Router is a device that
Interconnect.
interface.
Network. Okay. That's it. Bharti. From this side. జాగ్రత్తగా అయితే yes. Girish,
Used to connect to different networks.
used to connect
To different networks.
to different network and then
And route use basically route.
Mhm. Okay.
Share data packets.
Data packets. Okay. So till now, what we have seen, like the switches, they used to deal with the MAC addresses, and based on the MAC addresses only, they used to forward the data frames. Okay. In router, it is what it's a layer 3 device which will help us to forward the data between the network, or I can say different network, I can say. Yeah. So here, even it will help us to find the best path if it is having multiple, just to reach the destination. Understood? So in this layer 3, the two devices works. They behave same here, like router and layer 3 switch, or even we can say it as a multi-layer switch. Clear? So today we're gonna start with routing. So what exactly routing is? Based on the IP addresses, just to find the best path. Okay, if it is having multiple, just to find best path, we use this routing. Okay. Can see here what is routing. So it's a process of selecting a path across one or more networks. What I said? It's selecting the best path to forward the data packets towards the destination if it is having some multiple path. Okay. So the principle of routing can apply to any type of a network, from telephone network to public transportation. In a packet switching network such as internet, routing selects a path for internet protocol packet to travel from their origin to the destination. So it is not only in the local network, or it is not only in the your WAN or ISP. Okay, it will help you into any network. Okay, just to find the best path. I mean, on behalf of some, I mean, by using some, what do you call, some algorithm it uses. Okay. So these internet these internet routing decisions are made by specialized pieces of network hardware called router. Okay. So next is what exactly the route is. So sometimes I use a route or a network. Okay, both are same, network or a route. Okay. So you already know that the router maintains the routing table. Okay. Using this IP addresses only, it maintains a routing table. Whatever the network which will be there inside that routing table, sometimes it is also called as what? A route. Okay. So route is the best path selected by the router to reach from source to destination. What is a route? in routing table, you will be having only best path. Okay, based on some again some what do you call some metrics and some algorithm it uses in dynamic. Okay, based on some those algorithm or metrics. Okay, it will maintain only best path. In remaining, it will not be maintaining into the routing table. So for that, it will be having some different table. We are going to discuss about that later. Okay, but what is this routing table? This is what you can see here. It's a collection of routes to transfer the data from one domain to another domain. This is the best path. It is going to maintain in the routing table. Okay, so you already know what is an IP address. What is the IP address? I know it is internet protocol.
It's a unique.
It's a unique address that is given to the devices.
Device.
Okay, just to find those devices into the network. Okay, so we have a lot of types in the routing. Okay, not some, a lot of. So in that first one, we have static routing. Okay, in this static routing also, we have some three types. First one, by using next hop. Okay, and second one, we have exit interface. Okay, and third one, we have floating static. So these are the three different methods we use to configure this static routing. Okay, next we have default routing. So it's the only one we have in this one. Next we have the dynamic one. Okay, here in static we are going to inject the routes which are not there in the routing table. I mean which are not directly connected to that router. Okay, inject means what? We are going to add into the routing table manually. Okay, what happens in the dynamic? Automatically they will learn. Automatically the routers will run based on this IGP and EGP protocols. Okay, again this dynamic protocols are again divided into two types. One is the IGP and second one is the EGP, interior gateway protocol and exterior gateway protocol. Okay, and in interior gateway protocol again we have three types. One is what? Distance vector protocol. Okay, and second one is the link state protocol and third one is a hybrid protocol. These are the three types we have in the interior gateway protocol. Okay, and in EGP we have only one, that is a path vector. That is also having only one protocol, that is a BGP, border gateway protocol. Okay, and in distance vector protocol again we have two types. One is a RIP, it's not rest in peace. Okay, I said it's a, what is that? Routing information protocol. Okay, and second one is the IGRP, interior gateway routing protocol. And then we have a link state protocol. In that the first one and mostly used OSPF, open standard, open shortest path first. Okay, next is ISIS, intermediate system to intermediate system. Next we have hybrid, that is EIGRP, which is a extended version of this IGRP, enhanced interior gateway routing protocol. Okay, so these comes under IGP. Okay, and the only protocol we have in the BGP, that is border gateway protocol in the EGP, exterior gateway protocol. Okay, in your syllabus in CCNA we don't study IGRP because it is retired, and even ISIS also. Okay, you have only OSPF and EIGRP. Not officially this EIGRP. Yes, we will teach you what is this, and even I'll take RIP also. Okay, so only these three dynamic protocols we are going to learn. This BGP is an advanced level. Okay, that you are going to learn it in CCNP. Okay, So don't worry if you are trying for this CCNA exam also. So there only they will ask about this OSPF. Okay. And very basic about EIGRP, because the remaining are they just removed from the CCNA syllabus. Okay. So I hope you already know that what is loopback interface. What is the loopback interface or loopback address? What is loopback address? Remember?
127.
127? The whole network? Classic? Loopback कहाँ से कहाँ जा रहे? Yes. And I know that, but what is the range of that one? Hmm. Good. Very good. Keep it up. You think only 127? I'm not getting definite answer. Bharati, I guess. Good. Keep it up. Yes, he's hiding. You only. Don't remember? Good. Mr. Shah, what is that? Network address of what? Classic.
Means it range is 0 to 127.
Huh.
127 is the loopback address.
Loopback address is nothing but what? They are the logical addresses. They are created on a routers just to test the network. Okay. So the range is what? I mean the network address 127.0.0.0. Okay. And this is also called as what? Localhost. Okay. Yeah, loopback interfaces are logical interfaces, and they'll allow you to assign an IP address to a router which not tied to a physical interface. Can we route this IP address of this loopback address? No, we can't route that one. Okay. So because they don't have any physical attribute, which can fail, loopback interface never go down. Okay, it's a logical interface. It's a logical IP address that we are going to assign it on a logical interface, so it never goes down. Okay, and loopback addresses are treated as what? It's a separate broadcast domain. Okay. So the first method of routing, what is that?
Static.
It's a static routing. What do you mean by static? Static means what? You are manually adding the routes. Okay, you can see here, it's a process in which we have to manually add the routes in routing table. Okay, and the AD value of this static route is 1. So we're gonna discuss about this AD value later. Okay, just understand where AD value of the static route is what? 1, because this is very important. The AD values of all these routing protocols, what we have, they are really important. They may ask in interview. Okay, so what is static routing? We are going to inject or add whichever the routes which are not directly connected to that router, which are not there in the routing table of that router. Okay, just to make the communication possible from one network to another network into the topology. Okay, so what is the advantages of having this static routing? You can see here, no routing overhead for router CPU, which means cheaper router can be used to do routing. What do you mean by overhead now? See, overhead means what? Again, if you take the dynamic routing, they will be coming with their own headers and what you call the algorithm and all. Okay, dynamic one. Yes. So there they are going to increase the overhead. Overhead means what? The process or a traffic on that router. Okay. But here in static routing, administrator is going to directly inject into the router. Here the routers, they are not going to learn automatically. Administrator is going to inject or add the routes into the routing table of the router. Okay. There the processor, I mean the CPU process is not much there. Understood? So that's the reason even you can go for a cheaper or a small router you can use here. Yes. So it adds security because only administrator can allow routing to particular networks only. Yes, obviously only network administrator know which routers or routes he has added into that routing table. Okay. If it is dynamic learning, even the administrator has to check which routes I have in my network. If it is learning dynamically, then the administrator has to check or he has to troubleshoot what kind of routes I have in this router's routing table. But when it comes to static routing, he only added those routes into the routing table. Then obviously he will be maintaining the log of that one. Okay. And low bandwidth usage because, sorry, between the routers. Why? Why low bandwidth usage will be there? Because again, it is not a dynamic process. It's a static process. Okay. They are not going to exchange the routes in between those two routers. So if they start to do that one, then the process will be increased and the bandwidth will be used more. Whatever the link we are connected between the routes, the bandwidth will be used more because the dynamic routes, they will exchange some hello packets for some certain period. Okay. The static doesn't do that. Understood? So that's the reason bandwidth will be less used here between the routes. So, but some still we have some disadvantages also. What are those? For a large network, it is hectic task for the administrator to manually add each route for the network in the routing table on each router. Yes, obviously, if you have a small network, then you can add manually. Okay. If you have a big network where you have n number of routes, so in that case, the static routes doesn't work. Static routing doesn't work here because it is kind of a hectic task to the administrator because he has to find what the network and then he has to find the next hop. What is the next hop? What is the exit interface? Okay. So finding all this, it's a big work to do. Okay. So that's the reason for a large network, they always go for the dynamic routing, and a small network, you can go for the static routing. Okay. And the administrator should have a good knowledge of topology. And if a new administrator comes, then he has to manually add each route. So he could have very good knowledge of the routes on the topology. Okay. So let's suppose the old administrator, relieved from the company and one more new administrator comes in. Again, he has to see what kind of routes I have in the network. Okay. So that's kind of what you call again the learning process, I can say, for that new administrator. So these are some disadvantage of having this static one. But I can say this is a secure routing process. Why? Why it's a secure one? Because it is not learning it dynamically, we are adding it manually. Okay, only administrator know what route I'm adding. Understood? So that's the reason it is called as what? Secure routing process. Clear? So this is the syntax of this, what do you call? Static routing. Okay. If you want to add a route statically, you have to say IP route. Okay. This is a term we have to use for the static and even for the default also. Okay. So IP route space network ID. What is network ID? This is a network ID of that network which is not there in the routing table of this router. Okay. Next, we have to give the subnet mask of that one. And then we have to give next hop, or even you can say the exit interface. Exit interface. Clear? Understood? For example, you can see IP route and this is 192.168.10.0. 10.0 is nothing but what? It's a host ID or network ID? It's a network ID. And next we have subnet mask, and then we have next hop it is. I'll tell you what is next hop and all. Okay. Done. Any doubt in static one? No? Okay. If no, then directly we'll go to your favorite CPT and we'll try to. You want me to do it fresh or I can take the same one?
Do the fresh one.
Okay. Okay, I'm gonna take this 2911 router. Okay, it's a 2900 series, and I'm gonna take 3 routers. And 3 switches. Okay. This is what the networks they will be here, like 192.168.1.0 network with a slash value 24. And here it will be like 192.168.2.0 with a slash value 24. And here it will be like 192.168.3.0 with a slash value 24. Okay. In between these two routers, I'm gonna use 192.168.4.0 network with a slash value 24. And in between these two routers, I'm gonna use 192.168.5.0 the slash value 24. Okay, so these will be the network IDs. Okay, network IDs, network addresses. In the same network, I'm going to assign the IP address for this PC also and this gateway also. Okay, and here the gateway will be 192.168.1.10 with a slash value 24. And here the gateway will be 192.168.2.10 slash value 24. And here 192.168.3.10 with a slash value 24. And here the IP address will be dot 1 the slash value 24. And here the IP address will be same .1 slash value 24. Here also .1 slash value 24. Okay, let me write it like this, 3.1, and here it is 2.1, and here it is 1.1. Okay. I hope you got it right, everyone. Now let's assign the IP address. So I hope you know that what is the default gateway?
0.1.
Default gateway. What do you mean by default gateway? Yes. Don't know. I explained it, right? Default gateway. Sorry. It's very simple. Default gateway is nothing but what? It is used for communicating to the other network or host. Okay. For example, if this PC, which is into 192.168.10.0 network, and this PC, which is into 172.160.10.0 network, okay, they are totally into different network. Yes. And how this, I mean, whenever this PC wants to be ping with 172.160.10.1, yes, we always say that if you want to talk with a different network, you just come and meet this one. This one means what? The IP address I have assigned on this interface, router interface. Okay. And once this reaches here, it will check, router will check its routing table. Okay. Do I have any kind of a route which is having a name or a number that is 172.160.10.0? Yes, I have. Then I'm going to forward it to that network, that interface, I can say. Okay. This is called as what? It is a path. It is a gate through that the network can talk with a different network. Okay. And even I have taken this example also, right? If you want to go out of this room, then you have only this gate. Okay. So instead of this, you don't have any gate. Yes. If I ask you to go out, you will be going out of this only. Yes. Like that. Now let's come for the I hope you already know that like how to assign IP address here. 192.168.1.1 and 192.168.1.10. This is the default gateway. Let's assign the IP address to the second PC. Here it will be like 192.168.2.1 with 192.168.2.10. And the last PC 192.168.3.1 and 192.168.3.10. So this is the IP addresses we have assigned to the end devices. Yes. So let's go to the router configuration now. Let me take this bit side. Okay. CLI say no, and then enable, and then config. Okay. If you check the routes here, do show IP route. Still, I don't have any routes here. Do I have any route? This is how to check the routing table. How to check? Do show IP route. What is that? Do show IP route if you are in global configuration mode. What if you are not in, you are in privilege mode? Just show IP route. Okay. I hope you already know that. Yes. If you are in global configuration mode, just if you want to use show command, in that case you have to do show. I mean use do show. Okay. If you are in privilege mode, then directly you can use show. Okay. Now, Yeah, you have to go to the every interface. First, you have to assign the IP addresses. So IP address, sorry, interface gigabit Ethernet is 0/0. Okay. So what I have to assign those on this gigabit 0/0? What network I have to assign? What is the network ID? 4.0 network I have to assign. Okay. So in that, I'm going to take the IP address as 192.168.4.1. 4.1. Okay. Slash value is 24. Then what will be the subnet mask? Done. Enter. After this, we have to give no shutdown. Otherwise, the interface will not be up. Okay. So after giving every IP address, please practice to give no shutdown. Okay. Enter. Yes. Exit. Then you may ask like you have given no shutdown, but still this interface is down. Why? Because the opposite still down. Okay. Next, go to the interface gigabit Ethernet 0/1, where I have to assign 192.168.1.10. Okay. IP address will be 192.168.1.10. Okay, with the 255.255.255.0. Just say done. So this is up now. You can see here. This interface is up. Done. Now the configuration of this router 1 is done now. I mean the IP configuration is done. Now let's go to the second router. On gigabit Ethernet 0/0, what IP address I have to give? 192.168.4.2. Okay. And slash value is what? 24. According to that, 255.255.255.0. Next, no shutdown. Now you can see the interface is up. Yes. Now let's exit from this interface and go to the next interface. That is gigabit Ethernet 0/1, where I have 5.1. Okay, because I have to use a 192.168.5.0 network here. Okay, on this 0/1, I'm going to use a 5.1, and the router 3 0/0, I'm going to use a 5.2. Okay, so 255.255.255.0, and just say no shutdown and exit from this one. Okay, last one, that is interface gigabit Ethernet 0/2, where I have to assign the IP address, that is 192.168.2.10 with 255.255.255.0, and then just say no shutdown exit. Done. I've assigned the IP addresses on router 2 as well. Understood? Let's go to the router 3. Why this interface is still orange? Yes. It's done, man. Which one? We are not going to do anything in the switch routing. Yeah, that's what. Why? Yesterday only we studied it, right? It's because of the STP. Okay. 30-second, right? I didn't know you'll forget it this too early. Yes. Next, interface fast Ethernet, sorry, gigabit Ethernet 0/0. Which IP address? 5.2 with 255.255.255.0 and then no shut. Exit from this and interface gave it in the /1 and the IP address will be 192.168.3.10 with 255.255.255.0. After this, no shut down. Okay, exit from this one. Done. Let's go to the, still you can see there. Because of now let's open the routing table of all these routers. Okay. Now I'm into privilege mode. So that's the reason I'm giving it as what? Show IP route. Okay, there you go. This is the routing table of the first router. What it says? Here you can see some codes. These are some codes. Okay, the codes of routing. L means what? Local. It's a local network. And C means what? It is actually assigned on that interface. The IP address which is assigned on that interface, which is not changeable. Okay, you can see here. First one, C 192.168.1.0 with a slash value 24. It is directly connected via gigabit Ethernet 0/1. Where it is connected? On this one. G 0/1. Okay, it is directly connected. Before routing, okay, if you open the routing table, it will show you only directly connected routes. Okay, so according to that, how many routes will be there in the second router? Second router. How many routes will be there? How many routes will be there? Three routes. One is 192.168.4.0 network and 2.0 network and then 5.0 network. What about third network? Sorry, third router? Only two. Only two routes are directly connected. One is 5.0 and second one is a 3.0. Okay. So same you can see here in the first router also. You can able to see only two routes. One is 1.0 network and second one is a 4.0 network. Okay. So it says that at L 192.168.1.10 with a slash value 32. Why 32? Yes, why 32? And here above it is saying that 192.168.1.0 with a slash value 24. And here it is saying that 1.10 with a slash value 32. Why is that?
It's a assigned IP for that
Exactly.
0/1.
It is assigned IP, okay, locally. Understood? It is assigned IP locally to that interface, okay, which is not changeable. So that's the reason all the 32 bits are given to that interface only. So that's the reason they call it as a local IP. What is the network address of that one? That is 1.0. And what is IP address assigned to that interface? That is 1.10, the slash value 32. Okay, so both are connected via gigabit Ethernet 0/1. Next, we have one more network, that is 4.0 network. So there also you can see the same thing. 4.0 network is a network address and 4.1 is a local host ID on that interface. Which interface? Gigabit Ethernet 0/0. Clear? Done. So let's go to the second router. Pratik, tell me what is the command to check the IP address? Sorry, the routing table. Sure.
Do so.
See, you don't need to type the whole command. Okay, you can see there. I'm just writing it as a do shipRou. That's it. It will help you. Yeah, how many routes you can see here? three routes. As I already said you, these are the three directly connected routes. One is 2.0 network, second one is 4.0 network, and third one is a 5.0 network. Okay, and even you can see connected and the local addresses. Okay, let's go to this third one, to show IP routes. There also you can see two network, 3.0 network and the 5.0. Clear? Now, no. Yes, Murali, tell me. Which network I have to add into this routing table of this router 1. If I want to complete the communication in this whole topology, okay, which routes I have to add into the first router? Yes, tell me. Currently it is having two routes. One is 1.0 network and second is a 4.0 network. So which route I have to add? One 192.168, 2.0 network, the slash value 24, because that is also not directly connected to this router 1. Okay, if I want to talk with the 2.0 network, I have to inject it into the routing table of the router 1. Okay, and next is what? If I want to talk with the 3.0 network, I can't only add this 3.0 network. In between, we have one more network, that is 5.0 network. If you don't add this one, it says that I don't know who is 3.0 network. I'm not going to allow you because you don't have me in your routing table. Okay. So you have to add 192.168, 3.0 network with the slash value 24 and 5.0 network with the slash value 24. This is in the router 1. What about router 2? One dot zero and 3.0, because 4.0 is directly connected, 2.0 is also directly connected, and even 5.0 also. Okay, so only doesn't have 1.0 network and the 3.0 network. Okay, for that you have to add only two, 192.168.1.0 network with the slash value 24, and then 192.168 3.0 with the slash value 24. Okay, and on router 3, again we have to add three routes, 1.0, 4.0 and the 2.0. Okay, and already it is connected with the 5.0 and the 3.0 network directly. Okay, so 192.168.1.0 network and 2.0 network, and last one 4.0 network. Understood? So this is what we have to add with the help of first one, next hop IP address. Okay, what is hopping? I said when we were discussing about the TTL, at that time I said hopping. TTL in the IP header, remember? Time to live. Yes. Hop means what? Just one jump. Okay, jump. That's it. Okay, let's suppose if this 1.0 network want to talk with the 2.0 network. Okay, how it can find? First it will go to, first it will understand that this is not my local network. This is a different network. Then it will go to the default gateway. You already said it, right? If you want to talk with a other network, you just come to me. Come to me means what? Go to default gateway. Okay, I will help you. Yes. And in this router, you have added, what is that? If you want to talk to the 2.0, just come to me and take a jump. Then you will reach what? Router 2. On that router 2, it is directly connected, and that router is going to forward that traffic towards the 2.0 network. Okay, this is called as what? Hop. Next hop. Yes. Again, it's a what? Playing of what? Routing table here. Yes. Let's go and configure the static routing. Okay. So what is the term? I said IP route. Okay. For that, you have to go into the global configuration mode and you have to say IP route. Understood? Next, if I say question mark, it says that what is the destination prefix you want to add here? Destination prefix. That means only network ID, not the exact host ID. Understood? So what is the network ID here? Now I want to add this 2.0 network. That is 192.168.2.0 network. Okay. If I say question mark again, it says that what is the destination prefix mask? It was like 255.255.255.0. And if I say question mark again, it will be giving you like, you want to forward it to whom? Like forwarding router's address. It is nothing but the next hop. Okay. Or else even you can use the interfaces also. This is for what? This is for the exit interface. Okay, that we are going to discuss it later. Done. Just give it the next hop. So what will be the next hop here? Next hop IP address. Next hop. Hop means what? I said one jump. If it jumps once, then it is going to reach this gigabit Ethernet 0/0 of the router 2. What is the IP address I have assigned on this 0/0? That's what the next hop is. Okay. Did you get what is next hop? The IP address which is assigned on the next hop interface. Okay. And exit interface, here you have to give the exit interface name, like gigabit Ethernet 0/0, 0/1, 0/2, like this. Okay. So here 192.168.4.2 is the next hop. So do I have any other way or path to reach these 5.0 network and 3.0 network? No. Do I have? No, right? This is the only path I have to reach 2.0 network, 5.0 network and the 3.0 network as well. So every time the next hop will be same. Understood? That is 4.2 only. Yes. So here we just use a up arrow. Okay, it will give you the previous command what we used. And obviously we have to use the same next hop. We just need to change what? Network address, network ID, I can say. So here I'm going to add 3 and enter, and one more, that is 5, enter. Done? Is that done? Now let's go to the second router. Which network I have to add here? IP route. Okay, one is 1.0 network and second one is a 3.0 network. Okay, so for that, first one 192.168 1.0 network. Okay, and mask will be 255.255.255.0. Now tell me the next hop.
192.168.4.2.
4.2. It's a 4.1 because just see the direction where it is there. Okay, so just to reach this 1.0 network, we have this router 1 in between. Okay, if we take one jump, it will reach 192.168.4.1. Okay, so the next hop will be 4.1. For what? For 1.0 network. Okay, just enter. And for the second one, that is 3.0. What will be the next hop? 5.2. 5.2. Okay, and that's it. We have to add only 2 routes here. Done. Let's go here on the third router and check it. I mean, add those routes. What route I have to add here again? 192.168.1.0 with the 255.255.255.0, and then next hop will be 5.1. Every time it is 5.1 only because it doesn't have any other path to reach other network. Okay, so 192.168.5.1. This is the next hop. Enter. We have to add 2, enter, and one more. 4. Done. Done. Great. Now let's see the routing table of each router. Whatever the routes we have added, is a added or not. Okay. Again, do show IP routes. There you go. What is this? Yes. S stands for what? Static. That means statically we have added into the routing table. What it says? You have added one route called 192.168.2.0 network with a /24. Okay. What is this one now? I said you, what is this? No, not explain that one, but I said what is that one? It is administrative distance value. For static routing, we have AD value as 1. Now, what is this AD value? AD is nothing but what? It is the trustworthiness of the route. Okay. What is this? It is used to rate the trustworthiness of the routing information received from the neighbor router. Okay. Whatever the AD value increased, then the trustworthiness will be decreased. Okay. If you are adding statically, this is what? This is highly trusted route. I can blindly send the data through this route. Okay. So it is directly connected. The AD value is 0. If it is having static route, then the AD value is 1. And for external BGP, it is 20. For EIGRP, it is 90. OSPF, it is 110. For rest in peace, it is 120. External EIGRP, 170. Okay. Internal BGP, 200. And if it is unknown, then they'll take it as a 255. So you have to remember all these AD values. Okay. So the route with the least AD value will be selected as a best route to reach the destination on the remote network. Okay, what I said? Whatever the route which is having least AD value, that is selected as a best path to reach the destination. Okay, so that's the reason they call it as what? It's a trustworthiness of the route. Understood? So, and the same route will be placed in what? Routing table. Yes. and it is an integer value which is ranging between like 0 to 255, where 0 shows that route is most trusted and 255 means what? That no traffic will be passed through the route. Okay. Yeah, that route is never been installed into the routing table. If it is having AD as 255, and if it is having 0, it is going to select it as a best path. Okay. This is what the AD value of that one. Okay. Next we have hop count. So in static we don't use that one. Okay. Again in some different what do you call protocols, dynamic protocol and on. Okay, we use a metric values. So we, with the help of those metric values, they are going to find the best path. Okay, so that will be mentioned here in this one. Okay, this is what? This is the AD value and this is nothing but the metric. Okay, and this is connected via 192.168 4.2. Okay, what is 4.2? This interface connected via 192.168 4.2. Okay, and remaining also you can see 3.0 network, same AD value. Okay, and it is also connected via 4.2. And one more we have 192.168 5.0 network, and there also you are having AD value is 1 and it is connected via 4.2. Okay, now let's check the second router routing table. Do show IP route. We have added only 2 routes here. What are those? One is 1.0 network and second is a 3.0 network. And 1.0 network is connected via 4.1 and 3.0 network is connected via 5.2. Okay. And on the third router, we have added 3, right? All via 5.1. One is 1.0 network, second one is 2.0 network, and third one is a 4.0 network. Okay, same you can see here. 1.0, 2.0 and 4.0 network, and all are connected via 5.1. Am I clear? Everyone? Okay. Now let's check the connectivity. Are we able to ping from this first PC to the last PC? Okay. Three dot one. Okay. Do you think we're gonna ping? Yes. First 3 packet got lost. Why? Because they are gifted to our packet. Sorry, our protocol. And then we got the reply. Now if you try to ping again, you will be getting the continuous reply. Okay.
There are 4 routers.
4 packets will be lost. Getting done? Okay. So this is what the static routing with the help of next hop. Okay. Now we can configure the same thing with the help of exit interface. Now I want to remove this routes. Whatever I added these routes, I want to remove. How to remove? Just say no IP route and to the same command what you are given here. Okay. So this is what the packet movement in the router. Okay. So I already learned, the PC is already learned the MAC address of the last PC. So that's the reason it is having the destination MAC address as well. But wait for that. It is 02. Yeah, it's a proxy ARP. Yeah, what it says, if you can see here, from where it is generated, 192.168, 1.1, headed to 3.1. This is what? Source MAC address. This is what? Destination MAC address of what? Of 3.1. Okay, let me show you. What is the MAC address of this one? D6BC, right? At the end you can see that D6BC. But what is that MAC address it is giving here? Destination MAC address 8802. Okay, here the router will deceive this PCs. Okay, how? By giving some proxy MAC addresses. That is called as what? Proxy ARP. If you can see here, 8802. Can you see there at the 0/1? Okay. Whenever initially, okay, when this PC tried to ping to the PC3, okay, PC1 tried to ping to the PC3, it generated one ARP. Okay, what it says, you just keep it here. You just keep this ICMP with you. Okay, I'll just take the ARP. What it will do, the router 1 will generate one more ARP packet to this PC. Okay, but that is also not directly connected to this router, first router. Then first it will learn the second router MAC address. Okay, let me show you the same thing with the packet. I forward this. Okay, it will go to the switch, and there it will be having only MAC address information. You can see there. Okay, and next it will go to the router. What the router will do? You can see here. Yeah, of course it is going from 1.1 to 3.1. Okay, so now what packet it got? From 9B772 it is heading towards a 8802, but the router changed it everything. What it says? Now the MAC address, the source MAC address is what? 8801, and it will be given to 7801. Who is 7801 now? The interface, that is 0/0 of the router 2. Can you see that? 7801 at the end. Okay, this is called as what? Proxy ARP. I mean, this PC get to know that if I want to talk with this PC3, I have to go and meet this 8802. That's it. Okay, so just forward this one. I'll go to router. router 2. Okay, you can see here how it is forwarding the data. First one, from PC3 to it went to the switch 3, and switch 3 to router 0, and from router 0 to now it is heading towards the router 1. Okay, you can see that it traverses from router 0 to router 1 and router 1 to router 2. Okay, now if you take a back here, now this router also changed this thing. What you can see here, it came as what, 8801. Okay, and at that time the destination MAC address was 7801. Okay, but it changed, it made it as what, 7802, and it given it as, I mean, the destination given address as what, C801. That is nothing but the MAC address of this interface. Router 3 is gigabit Ethernet 0/0. Okay, forward this one, and again router 3 will change this. Why? Why those 3 packets got lost? The routers were learning the MAC address of these. That's the reason the first 3 packets got lost. Understood? And why only 1 packet got lost here during this? I mean, I was pinging of this 2.1, right? Why only 1 packet got lost? Because already it learned the MAC address of this interface, and this router didn't know what is the MAC address of this PC. At that time, this was learning the MAC address of this PC device. That's the reason the first packet got lost and remaining all got the reply. Clear? If you check it, this packet, you can able to see again it changed. Now source MAC address become C802. That's nothing but the IP address, sorry, MAC address of this interface gigabit address 0/1, and the actual MAC address of that PC is what, D6BC. Okay, now it is going to forward that packet to the PC. Did you see the path how it took? Okay, now it reached here. Now again it is gonna create a reply for that. Okay, so this is how the packet will be flowing in this routers. Clear is it? It's okay. Online, any doubt?
No, I'm okay. Thank you.
Sorry?
Only 4 packets will be transferred for the first one. 4 request packets will be sent.
Hmm.
We are having 5 or 6 routers in the network.
5
Routers.
routers. Then again, you have to ping it again. Yeah. See, one more thing, let me tell you. In routers, if you are pinging, the iOS will send 5 packets. iOS will send 5 packets. If you want to see, you can see here. Ping, I'm on router 1, 192.168.3.1. Okay, it'll send 5 packets. Can you see 5 exclamatory marks? Yes, so that is 5 packets. If you're not pinging, it will get as a dot dot dot. If you're pinging, you'll get a exclamatory mark. Okay, the router iOS will find 5 packets at the same time, and this PC will send only 4 packets at the same time. Okay, during the ICMP. Understood? Okay, now the next one is what? What is the time? What is time? Will we have time? We'll finish this exit interface and the default routing. Okay. So what I'm gonna do? I'm gonna remove those route what I have added here. So how to remove? I said, just say no. Just take one this, copy, say no, and paste. One more. What is that? 5 is there, and one more. 3, right? Okay. Do show IP route. It's unable to say again only directly connected routes. Okay. So let's do the same thing with second router also. By that I can configure exit interface. Copy. Just say no and paste. Done. Okay. Now again I have to add the same route but with the exit interface. Okay. So I'll go on the first router, and then I'll add IP route. Which IP address to add? 192.168.2.0 network with the 255.255.255.0. Okay. What is the next? Sorry, exit interface will be on this router 1. Exit interface will be exit interface. Fast Ethernet. Gig 0/0, because this is the interface which is connected to other routes, not directly to the third router but directly to the second router. So that is the interface you have to give here. Gigabit Ethernet 0/0. Okay. So let's give the same gig 0/0. Okay. Metric is there. Okay. Forget about the metric. Okay. Now we have second one. I have 3. Okay. And I have 4 also. Sorry, 5. Huh? Yeah. So do show IP route. You can see there. Yes. 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 Okay. Connected via Gigabit Ethernet 0/0. Okay. So let's do the same thing with router 2 also. So IP route 192.168.1.0 with the 255.255.255.0, and the exit interface will be Gigabit Ethernet 0/0, and then for 3.0 network it is 0/1. Done. Okay. So if you want to check, do show IP route. There it goes. One is 1.0 network and second one is a 3.0 network where it is showing which is connected via gigabit Ethernet 0/1 and 0/0. Okay, so let's go to the third router. Just say IP route 192.168.1.0 network. Okay, with 255.255.255.0, and the next interface will be, sorry, exit interface will be only one we have, that is 0/0. And for 2.0 network same, and for 4.0 network also it is same. Done. Clear? So to show IP route. Yes. These two. Okay. Now let's try to ping. Pinging, and 2. See, whenever you practice it, okay, you just go to simulation mode. Yes, understood. Go to simulation mode and you will get like this. Yes, and go to edit files, filters, and try to take ARP and ICMP. You can able to see if you're trying to ping how packet is moving from one router to another router, and try to open every packet. There you will get to know that what MAC addresses we are having, what IP address we are having at each packet, at each level, at each device, I can say. Okay. So any doubt in next hop? Any doubt in exit interface? No? Okay. So one more we have, that is a floating static. We'll see tomorrow. So today we'll see this default routing. Okay. So what exactly is default routing? We'll see now. It's a very simple, like as when we use the default routing. When we use default routing. Yes. High number of networks. Okay. You can see here default routing. That means if the destination network is unknown. Okay. So basically, which is used in the ISP, where we don't know every IP addresses which are used in the internet. So in that case, what we use this default routing. Okay. So this is a method where a router is configured to send all packets towards a single router. That is nothing but the next. Okay. It doesn't matter to which network the packet belongs to. It forward out to the router which is configured for the default routing. Okay. Let's suppose we have this router and this is my ISP. Okay. So I have some network here and I don't know what kind of IP addresses we have in the ISP. What kind of IP addresses we have in this ISP, but I still want to talk with the ISP. IS means what? Again, I can say internet. Yes. So what it will do, I know what is the IP address I have given on this ISP. Yes. So I'm going to forward all the data traffic towards that one. And it is the headache of that ISP. So where to send that one and how to take the data back. Okay. So in that case, we use this default routing. So what it does, it doesn't matter like which network the packet belongs to, but it is going to forward out the router or a traffic which is configured to send. Okay. It is generally used with the stub routers, where a stub router is nothing but what? Which has only one route to reach all the other network. What is stub router? Which is having only one route or a link to reach all the other network. So that is called as what? Stub router. Okay. And here also the AD value will be 1. Understood? Next, the syntax will be like again the same IP route, but this time we are not going to use any destination network address. We use 0.0.0.0. That means what is 0.0.0.0? Yes. Network address of what? Of network address of all the IP version 4 addresses. Okay. So this means what? Any IP address with any subnet mask. Any IP address, any subnet mask, you just send the traffic towards this next hop. That's it. What it will do? It is going to send all the traffic towards the next hop, which may be having any IP address and any subnet mask. Clear? This is the syntax. Like you can use this one, IP address 0.0.0.0 with a subnet mask 0.0.0.0, where it is going to send that traffic towards 172.16.10.1. Clear? So let's check that on your CPT. Yeah, I don't have ISP here, so that's the reason I'm going to take this router as a ISP. Okay, and let's take a switch. And a PC. Here 192.168.1.0 with a slash 24. Okay, and the gateway will be 192.168.1.10 the slash 24, and in between these two I'm gonna give 192.168.2.02 with the slash 24, and here on this router I'm gonna create some loopback addresses like 1.1.1.1 slash value 8 and 2.2.2.2 the slash value 8. Okay, these are unknown to this router, but still it will be able to ping this 1.1.1 or 2.2.2. Okay, let's assign the IP address on this one. So here I'm going to give 192.168.1.1 and 192.168.1.10. Okay, this is the default gateway. Let's go to the router and assign the IP addresses. Let's take a, yeah. No, and enable config the interface gigabyte/0/1. What is the IP address here? Is that the IP address? No, shut down. I'm just interface gave it as 0/0, and here I'm going to assign the IP address as 192.168.2.1 with 255.255.255.0 and just say no shut down exit. Okay, let's assign the IP addresses here. No enable config interface gigabit address as 0, and this IP address will be 192.168.2.2 with 255.255.255.0 and just say no shut down. Okay, I've assigned the IP addresses here. Now I have to create some loopback addresses, loopback interfaces. So for that, what I have to do? I have to say, sorry, interface loopback 1. Okay, so I didn't say anything. I didn't say no shutdown, nothing, but it says that loopback address state is up, and even the line interface is also up. Okay. So give the IP address on this one, that is 1.1.1 with the 255.0.0.0. Okay. Exit from this one. One more thing, sorry, one more interface, that is loopback 2, and then the IP address will be like 2.2.2.2 and 255.0.0.0. These are the unknown IP addresses I have here. Okay. Now I have to do the IP routing. Yes, I know from ISP, I know where to reach. So here I'm going to do static routing. But from this edge router to ISP, I don't know where this 1.1.1.1, okay, and 2.2.2.2 are there. That's the reason I'm going to do the default routing here. First, let us configure the static routing on this one. So IP route, okay, to reach 192.168.1.0 network, because that is the only route which are not directly connected to this ISP router. Okay, so 255.255.255.0. Okay, the next hop will be 192.168.2.1, right? Done. So let's go to this router 1, and here if you want to do the routing, you just need to say 0.0.0.0. That means any IP address with any subnet mask, you have to go and reach 192.168.2.2. Okay, done. This is what the routing here. Yes, if you see do show IP route, it says that is asterisk. Can you see asterisk? This asterisk means what? Candidate default. Okay. Now let's go to PC. Try to ping. Did you see any 1.1.1 or 2.2.2 network here? No. If I say ping, pinging, even though this edge router doesn't have the route of this 1 dot network and a 2 dot network, still it is able to ping that unknown networks. Understood? So this is what is this? Default routing. Okay, if you check with that will also ping. Okay, why this first packet got dropped? Because of the ARP, it was learning the MAC address of this router interface. Okay, understood? Default routing. Yes. Okay. Still we have a lot of time. We'll go for floating static as well. See, by default it is a 255 on routers. Okay, how many packet it's lost?
One.
So 1, it is showing like 254. Okay. And just a second. See, when you saw here, or if you noticed, what is the TTL value here we have here? 125, 126. It is varying. Okay. When you saw here, it is 254. Okay. Understood? So, yeah, you just take it as a task. Let me see. Okay. Yesterday thing, one thing I said you. What is that? Did you check it? STP. Did you check it? BPD filter, BPD guard. You got the result? You got the result? Diresh, where's the laptop? You didn't? Yes, Murali. Why? Said it, right? Then? Tomorrow you are going to explain this TTL values. Okay? Not only him, I may ask anyone. Don't worry, I'm going to explain it later. Okay? But let us see like what answers will come up with. Understood? It's okay. We'll start this floating stack tomorrow because just we have 20 minutes. Okay? And that will not complete that one. Okay, online. We'll meet tomorrow at the same time.
Okay.
Okay. Till then, everybody take care and have a good day.